Okay, so here we go. So today we're going to do is we're going to use trigonometry to solve navigation problems, okay? Do you have a protractor? You're going to need a circular protractor. So take a minute, grab one of the ones that has a circle on it. Don't get the half ones, get a circular one, okay? Get the full circle. Looks like I need one too. All right. Okay, grab one that's got a circle. Yeah, grab a ruler. Protractor. Ruler. And a ruler, yeah, grab a protractor and a ruler. Yeah. Okay, so real quickly, before I do a whole lot, everybody look. Now, there is a protractor and there's a compass. A protractor draws triangles. You see the 0 here, 10, 20, 30, 40, 50. We are not going to use a protractor. I'm going to turn this around and we're going to use a compass. Okay? I have a protractor. My protractor is looking at 0 here. I'm going to turn my protractor this way. So I've got north here at 0 degrees. I have east at 90 degrees. South at 180. West at 270. Okay, everybody see the difference? Hopefully you do, right?
Yes, sir.
Good. So same thing here. Compass bearing. And my compass rotates clockwise. East 90, south 180, 270, and back to north, which is also 360 degrees. Okay, easy, right? So number 1, draw a vector. Now vector is just a fancy name for an arrow. That has direction and length. That's all a vector is. Anybody taking physics? Or has anybody taken physics?
Yes.
Oh, vectors, right? So if I draw a bearing of 140 degrees, well, okay, I've got it. First of all, I call it my compass rose. Okay, my compass rose, right? I just draw my compass rose. North, east, west, south. It is Friday, south and west. And 140 degrees would be right that direction there. 0 for north, 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, 110, 100, all the way 140. So I'm going to draw that in. And then, okay, there it is. I draw an arrow because that's the vector, okay? And I'm going to label this as 140 degrees. Okay, easy, right? That's my direction. That is also the same as south, 50 degrees. Let's see, south 50 degrees, no, 40 degrees, sorry. South 40 degrees towards the east, okay? Turn south, same thing, okay? So 140 degrees, the same thing as south, and then, I want you to see this. South and turn 40 degrees towards the east. See how that works? So same thing is I'm looking south and turn 40 degrees towards the east. Okay? That's bearing. Okay? We'll keep doing that so you get familiar with it. Okay? Now, okay, draw a vector diagram of bearing of 310. Oh, I can do that.
I like to put my compass rose down. That always helps me. I call it the compass rose. That's what it's kind of called. It's the compass rose. So I just like to do the north, east, south, west, and a bearing of 310 degrees is about there. Okay, all the way around. All the way around to 310 degrees. All the way around to 310 degrees. So we'll draw that in. 310 degrees. Okay. This is 50 degrees here.
Okay, let's see how I got 50 degrees, right? Here are 360. So if I went 310, 50 more. Okay with that, right? So another way to write this in bearing is we could say, well, look north, and rotate 50 degrees towards the west. These are the same. These are the same. So then, example 3, draw a vector diagram north 35 degrees to the east. We could probably do that, right? Okay, my compass rose. Okay, my compass rose down. Yeah. We're going to look north. And I'm going to rotate 35 degrees towards the east. About 10, 20, 35 degrees towards the east. Not too hard so far. Everybody agree? Okay, there's my vector. And I know this is 35 degrees. So with bearing, it's always north or south to start. Never east or west, okay? It's always north. You always either look north or you look south, then rotate. Never east or west, okay? So draw a vector diagram of south, 20 degrees west. Okay, I can do that. Draw my compass rose. Okay, draw my compass rose in there. Okay. So I'm going to look south. And then I'm going to rotate 20 degrees towards the west. So I'm going to look south. I'm going to go 10, 20 degrees towards the west. Okay, see I'm doing that? Look south. Look 10, 20 degrees towards the west. Draw in my vector. And it's going to be like that. Okay. About 20 degree angle here. Or you could say that is a 200 degree rotation. Same thing, right? These two are the same thing. Where did I get the 200 from? Right, 180 plus 20. Yep, nice. So this easy, right? Agree? Like the way you answer that. Say, come on, Mr. Davies. It's obvious. Thank you, Ellie. That's awesome. Okay, turn the page. Kylie's doing the same thing. Well, come on, Mr. Davies. It's obvious, right? Okay. All right, now, here's what we want to do. Here comes the math. Okay, 2 ships leave port at the same time. Ship A travels 12 knots at a bearing of 55 degrees northeast. So it's going to go north 55 degrees. At the same time, ship B travels 8 knots at a bearing south 10 towards west. Okay, now let me show you where you don't want to put port, because you got to start somewhere. Don't put port here. Don't, because this ship is going north. You're going to be off your paper. Does that make sense? This one's going to be looking south and 10 degrees this way. So I'm thinking maybe if I put port, maybe right around here, I can probably get this thing to look something like that. So it's always kind of nice if you're going to put it on a piece of paper that you put on the paper. So before I even draw it, I try to figure out where I want to put the port. Okay, that looks like a good spot. Way back here on this side, not a good spot. Okay, so I'm going to draw port. Probably right about here, I think. There's port. Now the ships are going to leave, so they're going to look at their compasses. So I'm going to draw a compass rose. And they're going to leave the same port.
Ship A. This should be ship A. Oh, there's another mistake for the day. Ship A travels, not ship A. Ship A travels 12 knots, bearing at north 55 east. Okay, so protractor. What do I have to do with my protractor? Oh, it's right here. Okay. So I'm going to go north, and then 55 degrees towards the east. So I'm going to go my 10, 20, 30, 40, 55 degrees towards the east, okay? Right, like that, okay? So I went 10, 20, I've got 55. I'll draw my vector in, but I'm going to draw my vector a length.
You didn't have the center of the compass.
Did I miss that?
I did on the
Oh, yeah. Wow, I'm just having a day, huh? 55. Thanks, Brittany. Oh, yeah, I was off, wasn't I? Thanks, Brittany. Okay, 12 knots. So I'm going to draw it 12. I'm going to draw a length of 12. I can shorten it, draw it 6 and call it 12. That would work also. There's a vector.
And then is it always going to be in centimeters?
Usually. Centimeters are so easy to work with because you can go to tenths, where inches are difficult, right? So what I did, Vince, you actually asked a really great question because my 12 knots, which is a length and a speed, I just represent it in terms of centimeters, okay? So in 1 hour, it's going to go this far. Does that make sense? In 1 hour, it's going to go this far. All right, now I'm going to label your angles. 55, right? 25. No, 35. Okay. Ship B, let's see what's going to happen with ship B. Ship B is going to go south and then 10 degrees towards the west. All right, like right about there. And I'm going to draw ship B with a length of 8 knots, okay? So I'm going to draw it 8 centimeters and say it's 8 knots. There's ship B, ship A, 10 degrees, right? And this is going to be 8 knots. Okay, I'll wait for you. So my ships are going in different directions. So now, we're going to let them cruise the same course for 3 hours. I have 2 choices. One is I could just make my lines longer. I could, but then I'm going to be off my page. I could, right? Or I could just change the numbers. You with me? So instead of drawing this 36, I'm just going to multiply it by 3 and say it's 36 because the picture is going to be the same. And I'll do the same thing with 8 times 3, and I'll make this 24 knots, right? Same shape, we've just scaled it differently, okay? Now, how far apart are they? Well, that's got to be this distance here. So they're a long ways from each other. I almost have side angle side. I almost have side angle side, right? I've got side, side, but I don't have the angle. Well, that's easy to get, right? So what's this angle right here?
90.
So yeah, with 10, 90, and 35, we'll get that interior angle, right? That seems easy. I'm okay. You guys with me?
Yeah.
Okay, so I'm just going to add those up. I'm going to go, okay, 10 plus 90, and I get about 135 for that angle. And now I really do have side angle side, which is the law of cosines, okay? Law of cosines.
And what was that interior angles?
So I've got 90, 10, and 35. And Lauren, you know where the 90 comes from.
Oh, yeah.
Due south, due east, right? So let's call this D for distance. And I'm going to set it up as distance squared or opposite squared. Opposite squared is equal to adjacent squared plus my other adjacent squared minus 2 times the adjacent times my other adjacent times the cosine of my angle, which is 135 degrees. Thumbs up? So it's really not that hard, is it?
Why did you multiply them by 3 again?
Great question. 3-hour trip.
Oh, okay.
So they're going to go 3 times as far. So I didn't want to draw it 3 times as long because it would be like super big piece of paper, right?
Yeah.
So just scale it, right?
Okay.
Good question. Thank you, Vince. So all right, I'm going to type that in my calculator. I'm going to go 36 squared plus 24 squared minus 2 times 36 times 24 cosine of 135. And I get d squared is equal to 3,093.88. But of course, that's d squared. So we're square root, right? Square root. Square root. That answer. Whoops, back up that answer. And I get about 55.6, okay? And that's the answer to how far apart they are, okay? In terms of knots, nautical miles, right? Nautical miles, which is a length, but a boating length, okay? Now, ship B becomes disabled, right? If ship B becomes disabled and drops anchor, ship A's got to turn around and rescue, okay? So ship A is all the way up here. And it's got to turn itself around, right? Now, 55 knots is a long ways. You're never going to be able to see it, correct? You're never going to see it. But you've got to rescue them, so you've got to get the correct compass figure. So I'm going to put my compass rose here, because that's where he's at, and he's going to look at his compass, okay? So draw compass rose right up there. So then he can look at his compass and decide which way to find him. So, okay, compass rose, let's draw compass rose up here. Okay. So, ship A's got to take their compass and look at that angle all the way there, okay? So we're looking for that angle. Now part of that I know is 180 degree rotation. You guys agree? So part of it is I've got 180 degrees for sure. Plus this angle right here. Let's call it theta, okay? This is not intuitive, but I'm going to help you. This is not intuitive. Okay? Music? Who's got earbuds? There you go. So watch. Start to see what I'm going to do?
Ah, okay.
Okay, now this is 55, right?
Yeah.
And we can get this from the law of sines. We can get this angle, whatever it is. We can subtract 55. We'll get that angle. Will we show it again? We know that this whole angle is 55.
Right.
If I can get, we'll call it angle A. We'll call it angle A. If I can get angle A with the law of sines, I'll subtract 55 from angle A and I'll have theta.
Please excuse the interruption.
Okay.
All winter athletes need to head to the gym
Oh, we gotta
now
stop this.
for testing.
Okay.
All winter athletes, please head to the small gym now. Thank
All right, I
you.
think you got it though, all right? I'm going to finish it up.
Yeah, no, I remember this from algebra.
Yeah, we did this in algebra 2. So, all right, so here's my 55. Here's my 55, right? Hold on, let me just put this in a darker pen. Here's my 55. Here's my 55. I want to find angle A. And we use the law of sines, so I'm going to go, okay, I'll go the sine of A over 24 equals the sine of 135 over 55.6, okay? right? Opposites, sine of A over 24 equals sine of 135 over 55.6. I'll multiply up to 24. I'll have sine of A equals my 24 times the sine of 135 divided by 55.6. I'm going to use my calculator. How many am I doing okay? Not too fast? Okay, it's kind of a cool problem. Well, I guess if you're a math nerd like me, yes I am. I think it's a cool problem. Divided by, that's why I made it up. And then, of course, we have to do the sine inverse, right? We have to do the sine inverse. Have to do the sine inverse of that 0.3052, blah, blah, blah. So sine inverse of my answer. And I get about 17.77. Okay, so angle A is a 17.77. Okay, so I'm going to put that in here, okay? All right, so 17.77. So then, to find theta, it's going to be 55 minus my 17.77, right? 55 minus my 17.77. And I have a 37.23, so theta is 37.23. I add that to my 180. 37.23, and we need to take a bearing of 217.23 degrees. Okay, do you want me to summarize when I'm done?
Can you go back to the why you have got the, I understand the log signs, but why did you go to the
Good, that's why I wanted to summarize. Yep, that's why I wanted to summarize.